All right, guys, so this is going to be the fourth video in our board bow building series. Now, in the last video, we finished this bow off and we took it outside and we shot it through the chronograph. And if I remember correctly, I think we were shooting about 136 feet per second, which is okay, but it's certainly not great. And I also mentioned that there was a couple of things that we could do to help speed this bow up. Now, I guessed the weight of this bow at about 50 pounds at 29 inches. Just as a baseline, I want to go ahead and get an accurate measurement on the draw weight of this bow. And so I don't have a bow scale. I don't normally measure the draw weight of my bows because it doesn't matter to me what they draw as long as it's comfortable. Now, I'm going to show you a quick and easy way that you can measure the draw weight with just a bathroom scale that probably everybody has. Now, I've got a piece of board here, 1x2, with a notch cut in one end, and then from that notch, from the bottom of that notch down, 27, 28, 29, and 30, I've got marks. Now, I'm gonna go ahead and just put this on this bathroom scale, hook the bowstring in that notch, and with all that on there, I'm going to zero out the scale. Now I'm just going to pull down to my 29-inch mark. And it's drawing 55 at 29 inches. So I was a little bit off. So now we can get into raising the speed of this bow. So I built this bow with this particular design because I wanted to build something that was very straightforward, very easy for the beginning bowyers to follow. Now, this is not the most efficient design, but it is a very safe design. When you build your bows long and wide, and especially when you back them with something like rawhide, if you have the tiller correct, there's very little chance of that bow breaking. But you kind of give up some performance when you really push a bow towards the safe end of things. There's a trade-off in bow building. On one end of the spectrum, you have a very safe design. On the other end of the spectrum, you have a very high performance design. Now, somewhere in the middle there is where we want to be, because at the very safe end of things, you have an inefficient bow. You have a bow that sometimes will have a lot of hand shot because there's a lot of leftover energy in the bow. We want this bow to transfer as much of that energy that we place into the bow to the arrow as possible. And when you do that, you can eliminate 95% of the hand shock that you experience with a bow like this. Now, this bow, like I said, has very long limbs, and that makes things safe, but it also robs efficiency. And so what we're going to do is we're going to cut this bow down a little bit. We're going to make it about 68 inches or so. I'm going to take about an inch off at each end. And what that's going to do is it's going to increase the draw weight. And obviously, if you increase your draw weight, you're going to increase your speed. But it's also going to increase the efficiency of this bow. These long limbs take a lot of energy to get moving. And so by shortening those limbs up, we're going to make this bow a little bit more efficient. Now, you may or may not want to increase your draw weight. I like a bow about 50 pounds. This one's already 55, so it's already a little bit above where I like to be. And when we shorten this thing, it's going to bump that draw weight up significantly. Now, I can still shoot this bow even if it's up 60, 65 pounds, but it's not as comfortable for me to shoot. And so if you don't want to raise your draw weight, you're going to have to end up retillering this thing and reducing the weight back down, which isn't really a problem. You just go back to the tiller and brack and continue to take wood off the belly until you reduce that weight back down to where you want it. Now, you're not going to get quite the increase in speed that you're going to see here when I shoot this thing through the chronograph because you're not raising the weight, but I think you will see a little bit of an increase in speed because you're increasing the efficiency of the bow. All right, so we've got this bow shortened up, and then I cut the string nocks back in it. So I'm gonna go ahead and string it up and just see how much that raised the draw weight. Let's put it on the scale. All right, so that's reading 60 pounds at 29 inches. So we raised the draw weight 5 pounds. Now let's see what this does as far as increasing the speed goes. $143. All right, so what we're gonna do now is we're gonna try to up the efficiency of this bow. By increasing the draw weight, basically we're just we're kind of taking the brute force path to increasing arrow speed. Now, that oftentimes isn't very desirable. You might not want to up your draw weight. But you can increase the speed of this bow and the efficiency of this bow by reducing weight in the tips of the bow. And what I mean by the tips is down here in this area. Anytime that you reduce mass in the tips of your bow, you're going to increase the efficiency because you're reducing inertia. And inertia basically is the propensity of an object to remain unchanged. An object at motion or in motion tends to stay in motion. An object at rest tends to stay at rest. And so when we draw this bow to full draw and stop at our anchor points, the tip of this bow is at rest. And when we have heavy tips, it takes a lot of energy to get those things moving. It also takes a lot of energy to get them stopped. So when that bow string slams home and you have heavy tips, that's where a lot of your hand shot comes in. It's a very inefficient bow when you have a lot of hand shot because there's a lot of leftover energy that remains in the bow and is not transferred to the arrow. We want as much of that energy to be transferred to the arrow as possible. And so the way I'm going to go about reducing the mass and the tip of this bow is I'm going to reduce the width of it down here in the limb tip section. I don't want to reduce the thickness because that's going to change the tiller of the bow. And plus, when you reduce the width of this bow, you can take a lot more mass off the tips than you could through the belly because when you reduce the width of this bow, the tips are going to remain stiff. But if you start removing wood from the belly of the bow, you're going to start kind of getting into creating a whip-ended kind of design where it really has a lot of bend down here towards the end, and we don't really want that. All right, so the first thing I'm going to do is just mark the center of this limb tip just so I don't get off to one side or the other because we're going to be reducing the width of this. All right, so I'm going to come down probably 10 inches or so. And that's where I'm going to start with my hand plane, starting to try to narrow this thing up a little bit. So we've narrowed that thing down pretty good. It was almost an inch wide down there, and now we've got our nocks are down around 1/4 inch. I'm just going to round this belly off a little bit. So now I just need to refile my string grooves there. All right, so I've got the string grooves filed back into this thing. Now let's just go ahead and put the string on it and shoot it through the chronograph again and see what she does. All right, let's see if lightening those limb tips up helped anything at all. I always shoot a couple of times through the chronograph and just get an average, because sometimes, you know, if you increase your draw length or decrease it even just a fraction of an inch, it's going to change the reading that you get. So. $144. $144. $145. All right. All right, so narrowing out the limb tips, increase the speed a little bit. It's not really going to increase it enough to really notice a difference. What it did do, though, what I could notice was there was a little bit less hand shot because we did reduce the mass on those limb tips. But I mean, we were able to increase the speed a little bit. Now, like I said before, if you don't want to raise your draw weight, you can retiller and bring that back down. After you shorten those limbs, you can bring it back down to your desired draw weight. Now, when you do that, just like I said during the tillering portion of the series, I think that was in video 3, you don't want to, when you shorten this thing, it's going to raise the draw weight, and you don't want to draw it, you know, if you have a 28-inch draw, you don't want to draw it at 28 inches and exceed your target draw weight of whatever it is. If it's 50 pounds, then you don't want to go above 50 pounds because you're just increasing the string follow, which is decreasing your efficiency, and so you're kind of shooting yourself in the foot if you do that. You want to retiller that thing and just keep removing wood off the belly until you get that weight back down where you want it, and then you can bring it to full draw. You're going to increase your speed a little bit. You're probably going to make the bow shoot a little bit sweeter. All right, so just as a comparison, I'm going to go ahead and shoot my hunting bow through this chronograph just so you can see what it does. Now, this is an osage recurve. It's 65 inches nock to nock, and it draws 50 pounds at 29 inches. And I think what you're going to see is that this bow, even drawing only 50 pounds, is going to shoot a whole lot faster than the 60-pound bow that we made out of the maple board. Now, that doesn't have so much to do with the material that the bow is made out of, but it has a lot to do, everything basically to do with the design of the bow. Now, like I said before, I made that maple board with straight limbs, just a very easy, basic bow, something that would get people started and get them a bow that would have much less chance of breaking. Now, this bow, on the other hand, is pushing things more towards the performance end of the spectrum. The recurve tips are increasing the early draw weight. So basically, early in this draw, the bow is storing more energy, and that is going to be, it's going to help this bow to transfer more of that energy to the arrow. Anytime that you can design a bow, whether it's just with backset or recurve or whatever, where the limb tips set forward of the handle when the bow is unbraced, that's going to be a more efficient bow than just a regular straight limbed bow. So let's see what this bow does. $155. All right, so I mean, you can see just through this example that there are some design features that you can take advantage of and incorporate in your bow that will significantly increase your speed and flatten that trajectory, which is really the important part. You know, the speed doesn't really matter, but what speed transfers into is a flatter trajectory, and that just makes your aiming a whole lot easier at those longer distances. But you know, you don't have to increase your draw weight to increase your speed. You can just incorporate some of these design features, and a lot of these things I talk about in my book, The Traditional Bowyer's Handbook. So I talk about these things in a lot more detail in the book. So if you're interested in building more bows, I would certainly recommend that you check that out, and you can get that on Amazon, or you can get signed copies at twistedstave.com, and you can get one of these cool shirts while you're there. So we'll see you next time.